give her a new role. She has those credentials, and likewise, whenever, and maybe she loses access to an old system. That just needs to work. To avoid this case of not knowing where credentials are, not being able to associate identity with those credentials, and make ourselves secure from development to production. DevSecOps is another bullcrap term I really hate. It implies that security should be the separate discipline that as developers we kind of do as well as our job. It's part of our job, or it's part of our job as an operator. People don't build bridges and then they worry about whether it's going to fall down afterwards. They do the work up front to make sure that the bridge is going to stand the test of time. I had another. Well, I'll fiddle my way through one more graphic. How about that? Just to give you kind of an idea of what I'm talking about. So, I kind of give the game away here, but I'm going to talk about Hashicorp Vault, which is the secrets management tool I've kind of used before. And again, really compare this to the previous diagram, what really the difference is that we're using Vault to manage all of those different secrets in each of our different platforms. And it's not an all or nothing. You can use, I think one of the key tenets of automation is that you try and do one thing first and you progressively get better. If you try and do big bang automations, these things never work. And anyone that has ever worked with a config management tool, like Puppet or Chef or Ansible, kind of knows that to be the case. But what we want to do is we want to have a secrets management platform which takes care of all those secrets and associates identity with those secrets and lets us associate policies with them so we can have time to live, so we can revoke them easily, so we can offboard users, etc., etc. And on to Vault. So there's open source and enterprise versions. I'm going to talk about the open source version. I used the enterprise version in my previous gig. Really all I want to kind of talk about there, the key concept is sealing and unsealing. So the kind of, think of it very visually as a vault. Vault's where we keep our secrets. Whenever you first initialize Vault, it's sealed. You can't access it, and that's by design. It uses an algorithm called I think it's Shamir's key sharing technique, which basically means that all of the data is encrypted with a master key. When you initialize Vault, it splits the key up into however many shards you want. And then you set a key threshold on the Vault that says, I need 3 key shards, for example, to unlock the Vault. It means that one person doesn't have the ability to unlock the Vault by themselves. They need at least 2, 5, 7 other parties. And that's, of course, it's configurable. And of course, that's by design. Again, back to that zero trust breach mentality. Assume that if somebody is going to either benignly or deliberately do something bad, that they will. And this is another kind of protection built into the Vault platform to account for that. Of course, it does have that mode, which will let it auto unlock. But you need to have something like an HSM or be using AWS key management in order to be able to do that. And just the key concepts to talk about here are, it has this idea of engines, secrets engines and auth engines and paths, which I'll get to in my demo, just mindful of the time. So starting Vault, is pretty easy. It's just one damage file or one apt-get package. Just download one big binary, no problem. And we started in dev mode, and the demo I'm going to show you here assumes that we've started in dev mode. Now, when you start in dev mode, it's already unsealed. Deploying this in production is much, much different. And again, the whole ceremony around unsealing, et cetera, and distributing keys is left to the exercise of the audience, should they want to run this for themselves. Just one small note, and again, that's kind of something I want to talk about as well. The one thing I love about Hashicorp's products is they try and force you to do the right thing up front. So that may seem like a pretty innocuous kind of environment variable to set. Well, the thing is that when you run the Vault command line, it assumes that you're using SSL. and it tries to force everything you run through SSL. Because this is running in local mode, I'm using HTTP only. You would never do that in production, needless to say. But this is purely for the purposes of the demo. So I swear I had another graphic, and I don't really want to. I really should. Bear with me 1 minute. If only I had some kind of elevator music to break the silence. We all know that tune, don't we? All right. So, what are we looking at here? What we want to do is, Bob and Alice want to access a database, and we have a set of credentials which we don't want to insert into any config file. We don't want to set environment variables. We want to dynamically load it at runtime. So what we're going to do in Vault is we're going to configure a secrets backend, or a secrets engine. So remember I talked about those concepts of auth and secrets. It's just a key value store. It's just a hash map, really. We're using KV2 in this case, which allows you to version credentials. But that's neither here nor there for now. The other thing which we're going to use is we're going to use a straightforward user pass auth engine, which is just username password, which again, we would never use in production. We would connect it to Active Directory, we connect it to GitHub, et cetera, et cetera. And we're going to use a policy to associate the users that are configured in user pass, use a policy to basically say what secrets they can and can't see. We're going to create 2 paths, and paths are really, just think of it as a file system. It's a directory into which you can put secrets. We're going to have Alice have one app path and Bob have another app path, and the idea is that we store a credential of some kind in there. Now, in the interest of time, I've kind of, that's Vault running. Let me just make my, so, Vault has an HTTP API as well. It's a real pain in the butt to work with. I wrote a bunch of Ansible playbooks to kind of make it a bit saner. But I will say that the user experience with Vault isn't great, but hopefully this is somewhat self-explanatory. So what I'm doing here is we're running, by this stage, by the way, Vault's up and running. And I have super user access to the Vault server itself. And it's all we're doing is we're going to enable 2 paths here, app1 secrets, app2 secrets. We're going to write a policy called app1 developer and app1 app role. An app role is a way to identify a machine, by the way, instead of a person. And the same for application 2. Let me just show you what these policy files look like. Let's see, app1. So this is written in a language called HCL, which looks just like JSON without, parent brackets, let's face it. But again, the language itself is pretty pretty straightforward. But again, I want to bring us back to that idea of that zero trust mentality. You can see here that this is the app1 user that I'm using to create that developer role that Alice and Bob are ultimately going to take. And what I'm basically saying is they can create, update, and read a secret, but and they can list secrets, and they can also delete secrets. Now, as a developer, that's the kind of thing you want to be able to do. But notice I also created this another policy for my machine role, and literally the only thing that role can do is read a secret. Now that assumes 2 things. It assumes that the component on the other side knows exactly which path to read. Why is that important? Well, enumeration is one of the oldest kind of pen test, reconnaissance techniques, in the book. What do you do when you get, what do you do when you want to pwn a box? Well, you port scan it, you enumerate the ports on it. By doing this, we're kind of already limiting. Again, we need that zero trust mentality, that level of paranoia that says, well, okay, even if this machine only ever reads a secret and is a perfectly benign user, I still don't want it to list everything that's in that directory, because they may have other things in there that that I don't want it to know about. But again, it wouldn't have permission in the first place. So what am I trying to kind of summarize here quickly in the 6 minutes I've left? It's that when you're talking about a secret, we should be what secrets management gives us is the ability to say, down to the level of basic Unix permissions, who can read and not read this. And in this case, I'll fast forward just in the interest of time, although I think there's nothing in here straight after, but I'll try not to tick the Mickey. If we look at what we do to create users, sorry, I think I'd have learned with this by now. This is how we enable the user pass, which is just the basic authentication, and create users. Obviously, this is for educational purposes, and basic auth is a really really flipping bad idea in the first place. I mean, it's almost like we're introducing the problem we're trying to fix in the first place for the purpose of setting up a system. Yeah. So where was I going with this? Yeah, so now, if I try, I have pre-created a secret. Not that. No, get. So this is an example of how I might get a set of my creds. I forget which user I'm logged as here, so let me try and, yeah. So what am I looking at here? I'm actually logged in as, I think I'm logged in as app2. So I'm logged in as Alice here. So I've tried to get a value from the secret store in app2, but I'm quite rightfully getting a 403. Now if I change that to app1, problem live demos, you can see that I get output back. Now that's not incredibly, I know that's really not incredibly groundbreaking, and that's why I spent so much time at the start trying to talk about that breach mentality, that zero trust model, because whereas reading a KV value store is really not that exciting. And one might say, well, you haven't really solved the other half of your problem as to how to rotate AWS credentials, etc., or even database credentials. We at least have kind of proven that what secrets management can give us is that ability to associate an identity with, with a secret. So I can actually, I'll log in Bob here, and hopefully I remembered to, yeah. So I've logged in as Bob now, and I'm going to try and run that same command I just ran against app2, and you can see that I get, like, not exactly groundbreaking, but with not an awful lot of code. Now I'm going to try and get Alice, the secret side of the other one, and I get a 403. Whoopee! Well, so if you remember one thing when you're looking at the docs for Vault, we think about policies, we think about secrets, and the ability to associate identity with that. I have 3 minutes. We're gonna work in this use case and model it, or sorry, update it, because, like I've said, we have a set of AWS credentials which are still statically defined. I've simply put them in a hash map, really, and put some SEL around it. But the killer use case for secrets management, in my opinion, is the concept of dynamic secrets. That ability to generate a set of credentials on the fly, which will only last for a certain amount of time, but give us access defined by those policies to a very limited scope of operations. So let me show you quickly how we set that up. And see which one, app roles. So, so what I'm doing here is I'm saying that I'm going to create a role for, let's say app2 machine role is for my provisioner. And I'm going to say that I can use that token a number of 10 times. The token will only last for 20 minutes. The actual secret ID number of uses is capped at, this is somewhat arbitrary right now, I'll say that. But the point is that you can actually say this set of credentials can only exist for this amount of time. And I'm associating a policy with it, which is app2 app role. Now, so let me just show you what that looks like, because I can't remember what I wrote in there. App2. Oh no, I want the policy. So again, back to what I was saying is that app role, even though Bob owns app 2 and can update and write secrets, I only want the machine to be able to read those secrets. And again, in the mindset here is up front when you're doing threat modeling is, well, what happens if somebody manages to inject a command into part of my build script that pulls those secrets out of secrets management? And what if they try to then enumerate the other secrets that are in there? I could be lazy with the policy and just say, well, just give me, allow all and all secrets. But that's the mindset we need to get out of, because that's, AI, machine learning, all that crap is well, useless for the most part, let's face it, in what we're talking about. But doing the due diligence up front to define policies and decide who can access what gets us 80% of the way there. I'm just mindful of time here, it's 1 o'clock. So I'll just show you what I've set up here is I have a Postgres database running. Let's see, it's File database. And what I've done is I've configured the database backend, which is going to talk to Postgres on my behalf and going to issue me credentials dynamically. Obviously, this is a test, so username, password, Postgres is for this purpose of this demonstration only. But as part of creating this engine, you basically then pass it a statement which says you can create a role in the database which matches my configuration. And in this case, we're wanting to grant only a select. And that's, if you're building dashboards or building a reporting tool, you don't need update permissions. You just need to be able to select. And you want to be able to issue these, rather than having somebody slacking you a request, could you share these credentials, or statically defining them. We want to be able to generate those on the fly. So all of this is pre-configured, and I am going to show you what this looks like quickly. Vault. So this is the command that actually then generates a set of unique database credentials for me. So if I run this, yeah, live demo, eh? So in this case, I'm logged in as, I need the root token. So there we go. So I'm going to log back in as the root user. Where is my terminal? Oh, there we go. I'm just going to do login. Right. Did I configure that? Yeah, there we go. Oh, let me finish, almost finish in this one point. What I've done here is I actually had a static piece of config. You saw earlier I defined the password statically. Again, Vault helps you be paranoid. Vault says, you didn't template that value, you didn't pass it in dynamically. Are you really, it warned me about it? But again, I get this kind of yellow text which tells me, yeah, you might want to rethink how you live your life. And now, hopefully, now I can generate passwords. Now, what's happening here is it's generated a username and a password which lasts for an hour and which is least renewable. Personally, I would be even more paranoid. I'd make it 30 minutes, probably less. I wouldn't have it renewable, for as a default. I didn't get to the demonstration part because I've run out of time here. But what I did as part of that config was I set up my policy to say, another policy to say app role 2 is able to generate database credentials and Alice and Bob can't. So again, not on the face of it, I suppose doesn't make for the most exciting of demos, but I think the implications of being able to let me just go through this. Yeah, I'll just demonstrate what I was showing already. It kind of goes without saying then that we haven't completely mitigated the problem of if a set of credentials leak, then we're potentially vulnerable. But what we have done is said, well, we only issue credentials that live for the exact amount of time they're supposed to. And secondly, they can only access exactly what they need to. We can even limit this by IP. We could say app role 2 from this IP is only allowed to pull secrets from that. And this in and of itself, considering that compromised credentials are still the single most, well, credentials are the prized possession for hackers to target. And now we've built a whole security infrastructure around it which says, well, you might get my credentials, but in about 15 minutes time, they're not going to be worth anything anymore. And I know exactly who had them, so I can trace through my logs to say that credential was pulled at this time from this IP. And now I've got a path that I can follow for any kind of kill chain analysis to figure out, well, exactly what went wrong. As opposed to, well, I don't know, somebody checked that config in 3 months ago and people are afraid to change the password because the production will go down. Okay, I'm only 5 minutes over. Come up and talk to me afterwards. I don't want to keep you away from your lunch, but thanks a lot for coming.